Hello, everyone. Nice to meet you. First of all, thank you for not leaving the room. I know it's a long day, and this is a finally last session, and I promise that I'll make it, interesting and beneficial for your time. Yeah. So today, enabling verifiable AI transparency via confidential computing with ManaTEE. I think you may find some of the words that you haven't heard of it, but so today's my goal is to make sure you understand those titles by the end of the session. So before I deep into, this is me. So I work at TikTok as a technology evangelist. So those are my, interests, personal and professionally. And this slide deck has been already uploaded to the event site. So you can download it and reach out to me if you have any questions after the event. Yeah, so I like to start with the question. So let's imagine your application is running on a server, processing your data in a memory. And now what if attackers physically has the access to your server data center and take out the server and inspect your memory? Do you think they'll be able to see the data or not? So I'm not going to pick someone here because I know it's a long day. So the answer is yes, that actually they can see the data because in the current computing, there's no encryption when it comes to memory. The CPU has to have a plain text, plain data in memory. So that's the current issue we are facing. And here is why computational computing came up with to resolve this problem. So I think everyone familiar with this, like data at rest, data in transit. I believe those keywords like encryption, database, HTTPS, VPN is something I believe everyone is familiar with. But data in use is something I like to focus on and how this can help you with the AI use case, which I'm going to show you later at the end of my session. Yeah, so protecting data, why is it challenging? Because there are so many areas that you need to protect. So not only your internal system, also from outside or from external services. And for example, if you just one of your server has been breached, then that access can be actually moved to other services. It's called lateral movement. So there are so many areas that you need to protect to secure your application and your data. So this is one of the key challenges that we are facing and where confidential computing can help with. Then what is confidential computing? Let's start with it. So this is the definition from Confidential Computing Consortium. So confidential computing protects data in use by performing computation in a hardware-based or tested trusted execution environment. So I'm going to explain this in more detail. And also for a lot of knowledge and data, if you go to Confidential Computing Consortium, which is under Linux Foundation, you will see more articles and blogs. And also there are many companies who are member of this consortium, like all the chip makers, NVIDIA, Intel, Samsung, even TikTok are there. So feel free to check out this website and you will have more detail. So then let me just continue what confidential computing is. So this is the physical machine, and this is your application, and this is your data. But technically, other application, even operating system and hypervisor can access your data. Because let's imagine one of your app has some permission issue, somebody has breached into your operating system, they can technically go to your data and even other operators. So this is trusted execution environment. The key concept is CPU has the key. That's the key difference. And then the data here is being encrypted by your CPU. So that way, only your application can access data, and other operating system and hypervisor cannot have that access. I mean, this is very simplified version of explanation, but because of the key encryption, there are a lot of things that you can do. Basically, setting some code policy, deciding who and which application should have, your data access, which I'm going to explain with my demo later. And another benefit of using computational computing is to use attestation. So basically, using the key, public key and private key, you can use it for attestation. For example, if your code has been executed in computational computing, with computational computing, they can give you the attestation report, which is basically hash key, that you can prove that your code is safe. So for example, let's say, hey, here's a proof that I'm a T, meaning trusted execution environment that you are expecting. So you can actually do the verification with the computational computing that I will show you in a demo. So here's a quick comparison to make it simple. So let's say HTTPS. So when you go to website, when you type HTTPS, how does the confidentiality guaranteed? It's guaranteed by the certificate, right? Public key and private key. So that way, the simple concept is here, is the key is in the CPU. So it's a similar concept. And what about the attestation? So for example, when you go to let's say tiktok.com, how do you know that website is TikTok? Because you type it, right? But also you see the green bar on the browser, and the attestation is coming from the cert, and the cert is guaranteed by your browser. So it's a whole PKI system. And in the computational computing ecosystem, the attestation is done by the report. So once the computation is done, the computational computing will give you a token that you can verify the result after the computing. So that's the key difference. And what is ManaTEE? Yeah, so ManaTEE is the open source project that TikTok has been developed, but also donated to Linux Foundation. So it's now officially Linux Foundation open source project. So ManaTEE is the framework that give you the control and visibility into confidential computing. So for example, although I explain what confidential computing is, you may have some uncertainty. So how can I use it? So there are a few ways to use it. You can go to any, AWS, Google Cloud, all the, major cloud providers. They have confidential computing function, so you can enable there. But with ManaTEE, we give you some framework that you can have a better usability with this framework. So this is ManaTEE. So basically, ManaTEE gives you the two stages. So one is the programming stage. So from here, we give you the Jupyter interface so that you can, play around with your data. But this is not yet computational computing. But once you're done with your coding, once you're done with your data analysis, then you can execute to the computational computing. So ManaTEE basically gives you the interface to play around with the code. And once you're done with the analysis and with your coding, then you can move to the execution stage where you can have the benefit of using computational computing. So this is the simple concept of ManaTEE. And then why do we have this diagram, this two-stage execution model? Because one of the key challenges so far we have with computational computing is little bit of performance overhead and also a little bit of unfamiliar interface. Let's imagine that you are coding, and whenever you code, whenever you compile, if you use computational computing every time, it will actually slow down your workflow. So basically, since we give you those two stages, one is programming stage, you can basically compile here in a way that you would normally do. But once you are done with the coding, then you can move to the second stage, which is computational computing, that we will give you the attestation report so that you can prove your code is safe and has confidentiality. That's the core concept. So use case, let's move to the use case, which is our today's main agenda. So those are the potential use case, like data analysis, ad measurement, which is actually TikTok's own use case. And also, if you have your own AI model, machine learning, you can run it in this two-stage execution model, then prove your AI model's framework with someone else, with the third party. So quick demo. So let's say this is the example that I'm the model owner. I have the AI model. And this is privately developed by my company or by myself so that I don't want to share it with someone else. If that's the case, I can just put my model here in the execution stage. But I want to prove my model is good. It's a great model. And I want to invite evaluators to run some script against this model. So using ManaTEE, evaluators can come to this Jupyter interface and basically running their evaluation script. But they don't have the access to see the model because using confidential computing, a TE, you can set specific permission only to run their evaluation script, but not have the access to my AI model itself. So once your evaluation is done, then here comes a attestation report so that you can use that token to prove someone else. So let's go to a quick demo. Yeah, so I will just skip this part. This is just basically explaining what I'm going to evaluate. So let me try to, I know these are small text, but so this is the interface that evaluator is going to see. So basically, once they come to this ManaTEE interface, you can basically install, your AI model. So in this demo, we installed the, harness evaluation model, and basically trying to run this model. So let me go to the second stage. So once the evaluation is done, then you can submitting a task. So here in this model, I'm not sure if you can see clearly that I'm trying to submit the job. So I'm not sure if you saw it. So basically, once you're done in this stage, you can submit your job, meaning that, I'm done with my analysis, I'm done with my coding, so I'm executing in the confidential computing. So let me go to, and then that evaluation, now you are examining the evaluation result. So just going to the script. So see, here is the result. Now you're checking the result. Okay, this is how it's been executed. Then you submit again here. So lastly, now you are done. Now your testing is done. Then you are downloading your report, which is the attestation report. Then, so attestation report is basically token. Oh shit, let me go to the second stage, yeah. You're basically downloading the report here. So it's basically token that you take this token that you can actually send it to someone else or just use it for your own use case. So you can go to the verification tool, pasting your token. I know those texts are very small, but basically in this token, there are so many details that you can prove with someone else. For example, it basically says this is the token that has been executed in the confidential computing. And also you can put other details such as location, such as your infrastructure like a GCP. And you can put your container information, so making sure your container has not been compromised. So I mean, those details, I recommend going to the event site and check the result so that you can actually see the small text inside. And another quick demo is the data analysis. So in the first demo, I explained how to verify your AI model. But in the second demo, is more like a data analysis use case. So for example, let's say I have the data. It's very important data that I need to make sure that it's safe. Whoever comes to this data, it's safe. But let's say I'm the data analyzer, that I need to use the data and analyze it as many as possible. So basically with this data, you can set different states. So when the data analyzer come to this Jupyter interface, I basically give them synthetic data. Hey, I'm giving you the data, but not actual real data, but synthetic data. So with this synthetic data, you can play around. Just do the analysis as much as you want to do. But once you're done with analysis, then come to second stage, which is execution stage. Then you will have the access to the actual data so that I will give you the attestation report. So that's the use case. So just explaining what kind of data I have used here. But demo here is that it's just similar because it's the same software. So basically, I'm come to this Jupyter interface, and I'm downloading the dependency and running the data analysis. But here, all these data are not actual real data, but more like synthetic data. Because in this programming stage, I don't want to give them my sensitive data because they are not protected. But I want to give the data analyzer the flexibility to train their data. So in this stage, our data analyzer basically play around. Just keep moving on. Then once they are done with the data analyze, then they go to the second stage. Hey, I'm done with my data analysis with your synthetic data. Now I want to see the result with actual data. So that's where he's moving into. Yeah, so basically submit the job, then the attestation report are given. And with that attestation report, you can basically verify your result itself. So basically key concept is, whatever I do, either data analysis or AI model framework test, I want to prove it with someone else or for myself. How can I prove it? Let's say I have a AI framework result. It's basically text, right? Anyone can basically edit the test result. The framework result was B, but I can just change it to A. Nobody can prove it. So now with confidential computing, you can basically prove your test result. So that's the key use case with ManaTEE. So I will just explain. So confidential computing is a valuable tool, not only for security, for privacy, but also can be integrated with, cloud. And with limited time, I will just share the links here that you can come to our open source website that, test around, and we have few blogs inside which explain more details than my slide. And lastly, and thank you for OpenSSF having me here and having the opportunity to introduce ManaTEE and Confidential Computing Consortium. And I'll be staying around here, of course, after the event. So feel free to reach out if anyone has any questions. Thank you.